So today I'm talking about the discovery and action of penicillins. Penicillin is an antibiotic drug, which means that it kills germs that are in the body that are invading, and it comes from this here, which is the Penicillium fungus.
Penicillium.
Penicillium fungus. And it was discovered in this is Alexander Fleming. He was born in 1881. In 1928 he discovered penicillin, or the Penicillium fungus. And he discovered it by accident really. He went on holiday and left a load of petri dishes out on the side, which had bacteria in them, and when he came back he realised that the fungus had killed off the bacteria. And when he realised what he'd done, he said, "That's funny." So to refine penicillium to make penicillin, which you can use in the body, so it's soluble enough to pass through the gut wall, you take corn steep liquor and lactose together with minerals and phenylacetic acid, and you put them in big fermentation tanks for 4 to 5 days, pumping in oxygen, because it's an aerobic process. At 25 to 27 degrees is the optimal temperature, and for all of your trouble you get 0.5% of the mass left is penicillin, which you then filter off, adjust the pH to using sulfuric acid, and by reducing it to pH 2 it means that it's soluble in the body. But how does it work in the body? Well, the bacteria that it attacks are either gram-positive or gram-negative. Penicillin targets gram-positive bacteria because it doesn't have this outer membrane, and it means that it can attack the peptidoglycan cell wall, which is constructed of amino acids and sugars, and looks a bit like this. So you've got the cell wall with alternating amino acids and sugars, and these different layers are held together by enzymes, which join up like this. And a chemical called transpeptidase links these two enzymes together, which creates a rigid wall. The process for this will say it looks like that, and it comes in and it clamps those together. And the way that penicillin works to stop the creation of the cell wall is the beta-lactam structure, which is part of the penicillin structure, and it comes in this square part. The conformation of it fits into the conformation of the transpeptidase, meaning that it can't perform its job anymore because this bit gets filled up. And so it can't actively play. If you think about it in this conformation, then it wouldn't be able to clamp together the enzymes, so it becomes ineffective. Meaning that the cell can't build up its wall, so the pressure inside of the cell causes it to effectively explode, killing the bacteria, which is the idea. But the bacteria is starting to develop a resistance to the penicillin antibiotics, and the first line of defence is beta-lactamase, which is this structure here. And this is an enzyme which it changes the structure of penicillin, especially the beta-lactam ring, which by a process of hydrolysis, it cleaves this bit here. That's the nitrogen version. And then, say it's trying to fill up this here, but it's the wrong conformation, so it doesn't fit into the transpeptidase.
Active cell.
Yeah, active cell, so it can't stop it performing its job like it has over there. Not only that, the bacteria can pass on its DNA to other bacteria. So it can pass on positive mutations for the bacteria. So, for example, it can change transpeptidase conformation itself. So, for example, it could look like that, which means that the penicillin won't work with it anyhow, and it can pass that on, and it's passed on from generation to generation of the germs. And that is the long and short of how penicillin works in the body. Are there any questions?
What do they do now for penicillin? Do they still do the fermentation?
Yeah, that's what I read about, and it said that that's how it's still done.
Right, good.